A repeating decimal is an example like this one here, which repeats itself after the second place. So the first two places are 4 and 7, and then that repeats itself indefinitely. Every repeating decimal can be written as a rational number. A rational number is a fraction. What does that mean? Well, a rational number is a number of the form a over b, where a and b are integers. Z stands for the set of integers, that is positive and negative whole numbers, including 0. Actually, b can't be 0. Okay, there's one exception here. A can be 0, but b cannot be 0. When we're talking about a rational number, we cannot divide by 0. Now, to write this as a rational number, what we can do is, first of all, notice that this is the same as 0.47 plus 0.0047 plus 0.000047 plus 0.00000047, etc. So for each new term we just insert two extra zeros. So the first two places are 0.47. To get the third and fourth place we have to have two zeros here. You can check that if we add up all of this infinite series, we will get this decimal. To simplify this infinite series a little bit, we could factorize out 47. 47 times 0.01 is 0.47. 47 times 0.0001 is 0.0047, and so on. Then you need to notice that what we have inside the brackets is a geometric series, where the first term a is 0.01. The common ratio r is got by taking any term, say the second term, and dividing by the previous term. When we do that, we get r equals 0.01. So if you want to write this in fraction form, we have 47 times 1 over 100 plus, well, r is 0.01, which is 1 over 100. So we have 1 over 100 times 1 over 100. That's a 1 with 4 zeros in the denominator, or 1 over 10,000. And we multiply this by r, which is 1 over 100, and we get 1 over a 1 with 1, 2, 3, 4, 5, 6 zeros, or 1 millionth. That's 0.000001. That's 6 decimal places. Since r is a number that lies between -1 and +1, r is 1 over 100, or 0.01, we can get the sum to infinity of this series. The formula is a divided by 1 minus r, where a is the first term, 1 over 100, or 0.01, over 1 minus r. R is 0.01 also. Calculating this, we get 1 over 99. And then we just have to multiply by 47. So we see that 0.47 recurring is equal to 47 over 99. Of course, if you want to check this, you take 47 and divide by 99. A much easier way to do this is to let 0.47 recurring equal x. Then we multiply this number in such a way that we move the decimal point from the beginning of the repeating part to the end of the repeating part. So we'd have to multiply this number by 100 in order to do that. So 100x is going to equal 47.47 recurring. Then what we do is we take this second equation and subtract this top equation from it. You can do that because x equals this, so we're subtracting the same thing from both sides of this. 100x minus 1x is 99x. 47.47 recurring minus 0.47 recurring is 47. So that leads us to the fact that x must be 47 over 99. So this is a much easier way. Here is another example. We have 0.8363636. The 36 recurs indefinitely. The first thing we should do is move the decimal point to the beginning of the repeating part. So we just multiply this by 10. If I call this x, if I call this number x, then 10x is going to be 8.36 recurring. Now we notice that the recurring part, or repeating part, has 2 decimal places. So we want to move the decimal point from the beginning of the recurring part to the end of the recurring part. So we'd have to multiply this number here by 100 in order to move that decimal point 2 places. So we have 100 times 10, that's 1000x, equals 836.36 recurring. And now, like before, we do some subtraction, because if we subtract, we can cancel out the decimal part on the right hand side. So I take this second equation and subtract this first equation from it. So I have 1000x minus 10x, that's 990x. And here I have 836.36 recurring. I subtract 8.36 recurring. The decimal part will disappear, and I'm left with 836 minus 8. We get 828, so x equals 828 divided by 990, and that can be broken down to 46 over 55. Of course, if we want to check this, you can go to your calculator, take 46, divide by 55, and we can check to get 0.8363, sorry, 0.83